All right, are you ready to draw some more triangles? Here we go. The next one that we're going to draw is going to be a scalene right triangle. So I want you to write that on this one. A scalene right triangle. Or, remember, it can be called a right scalene triangle. Either way, but we know something about scalene. It means that no sides are going to be the same length. And we know something about right. We know that there's going to be one right angle. So in order to do this, I think the easiest thing to do is to start off with that right angle. So what we would do is, we can just come up here and make a right angle. So if I go, I don't know, I'm going to start down here, like down here in a corner, and I'm going to go up a little bit, not very far. But what I want to do here is I want to make it so that no sides are the same, so I can't just go straight down from it. In fact, I'm trying to make a 90-degree angle. So I'm going to turn my paper, and I'm going to make an L, just right now, so you can see and prove that that is 90 degrees right there if I make it an L. But remember, I want this to be scalene, so no sides can be the same. So if I keep going down, that's going to be the same length as that one. So maybe I'll go just a little bit further, but not much. And I'm going to use my extra piece of paper. You should find a scratch piece of paper if you can. This would help a lot. And I'm going to start making some tick marks so that I know for sure they're not the same length. So I'm trying to measure this side on the left. So I put it at the vertex, and then I put a tick mark on my paper for how long it was. And then I'm just going to make sure that if I were to connect those right now, they wouldn't be the same. And they would not be. They would be a little bit off. So I think it would be good to connect them right now. If you go longer, it's going to be a lot closer to the side that it is right now. So if I put the vertex there, yep, it'll be a little bit off. I might actually make it a little bit shorter. And we'll see if that helps. Oh, actually, if I make it shorter, then it gets closer. Let me try this again. What if I made it longer? We go from here to that corner. Yep, they would not be the same. So I just use the vertex mark. They're close, but they are not the same. So here's how I would prove that. So scalene, right? I'm going to make these tick marks. I'm going to say, well, this one's 1, this one's 2, and that one's 3. Just meaning none of them have the same congruency marks. So I just show that with green. No sides are the same. Show the 2. I can't remember if that one had 2 or 3. One of these needs to have 3. We'll just have this bottom one have 3. And then, so we'll have 1 on the right, 2 right here, and then 3 down there at the bottom. Just showing that none of those sides are the same. And then you can tell that the last name is right because it has that right angle up at the top. So again, just a word of advice is if you're ever drawing any type of right triangle, start with that right angle so that you know for sure that you have it, and then go with what else you need to do. Okay, in the next box, I'm going to challenge us to draw 2 triangles in that box. So if you come down here to this bottom left square and take your black crayon, I have dropped mine on the floor, so that's always fun. Take your black crayon, and I think what I want you to do is to split it in half, going left and right, just like that, just so that you get another practice of drawing with me. Both of these are going to be isosceles. The first one is going to be isosceles obtuse, and isosceles acute is the next one. So down here I'm going to write isosceles, and I said obtuse first. You need to rewrite it the other way, just so that you get used to seeing them either way. Okay, so I know isosceles. That means isosceles. That means there's going to be 2 sides that are the same. It's the red. And I know obtuse. That means it's going to have 1 giant angle. Okay? So here is how I think this is the easiest way to think about it. Anytime when we've had isosceles, so we've only actually done one example of it so far, but I always think of it as like a girl with a dress, and she's got 2 arms. So Let me show you what I mean. So if I looked at that very first one we drew, which was isosceles right, you can see that these are her two arms. If I were to pretend to draw her head right here, right? So it would be like a girl with two arms. So that's how I remember isosceles has to have two arms on the side. And if it's obtuse, it means I need a really wide angle. So I would just start up here at the top, and I would come really far out to the side. And then I'm going to come really far out to this side. I want to make sure that that is not 90 degrees, because if it's 90 degrees, then its last name is right and not obtuse. And it looks a little bit, oh, it's not. Because remember, if I'm going to make an L from this line, it would go like this. It would be going straight. It would be going like that to make an L. So it is wider. I think, though, we could help make it a little bit wider. So if this is the tipping point, and I can come even further out like that. But remember, it has to have two that are the same. So I'm going to have to go as far out as that one. Looks like it came pretty far out to there. And then I would connect them. And I'm going to use my scratch piece of paper just to make sure. And remember, I want two sides that are the same. So if I measure from this vertex to that vertex, that's how long it is. I'm hopefully going to get the same measurement over here. I did not. It's a little bit longer over here on the right. So I do want to change that so that it is the exact same. So I am going to draw my angle mark in. It's not hard to fix. You just have to draw the other line. And then you erase the outside line. Don't let this be frustrating or confusing. It just takes a little bit of time and sometimes multiple efforts, and that's okay. Or maybe you got it on your first try. Who knows? So I'm just going to use my blank paper again to prove it. So I'm going to go from this vertex to that point and measure. I'm going to hope that it's now the same because I want two sides that are the same. There we go. It is the same. And then when I measure the bottom, it's definitely not the same from vertex to vertex. You can tell that that one's quite a bit longer. So she does have two arms here. Those sides are the same, and then this side is not. So in order to prove that, remember isosceles is red, so you're going to show the two sides that are the same. So I guess a good way to think about an isosceles obtuse is like a short, really wide, or really fat triangle. Don't do the bottom line because that's not the same as those. And then we're going to prove that it's obtuse. Well, I can tell right now, if I were to make those two angles, those are acute angles. See, they're acute little angles. To be a right angle, they have to be open up like an L. So I'm just going to come over here to try and see if this is a right angle or obtuse. I know it's not acute. Remember, if I'm going to make this vertex be 90 degrees, then it has to go straight up from the vertex. It would have to be like that on that line. That would have been 90 degrees. But I was not here. I opened up wider, which proves that that is obtuse. So I take my purple crayon and I'm just going to make that obtuse angle mark like that. You can leave the 90-degree line for proof if you want. You just usually make a dashed line so that you know it's not really there. But that would be an isosceles obtuse or an obtuse isosceles triangle. Okay? Down here below, this one is, I think, one of the hardest ones to draw. So good luck, okay? Wish me luck too. I'm going to need it. This one is an isosceles acute. So let's write that at the bottom. Isosceles acute, or it can be pronounced an acute isosceles. For an acute isosceles or isosceles acute, what you have to do on this one is you have to make all of the angles be less than 90 degrees. Remember, it can't have that last name of acute. The acute's going to be yellow. So we're going to have to be proving that all the angles we have here are acute, but only two sides are the same. So the easiest way to do this is do the opposite of, instead of having a wide, short triangle, we would make a tall, skinny triangle. So we would have like a top at the, maybe like clear up here. And I'm just going to go down just like that. And then I'm going to go down just like that. And then I'm going to close it. I do want to take a scratch piece of paper and make sure, again, I'm going to get rid of all of my other tick marks on my scratch piece of paper. I do want to make sure that they are not, that those two are the same. So if I measure vertex to vertex and make a dash, and then I bring it to that vertex, it should be the same. Yep, so those two were the same. If yours are not, you can erase and change the angle there. Those two are the same. And I just want to double check that it's not the same as the bottom. Obviously not. Look how far out my tick mark came. And it stopped right there. So good, I did that correctly. So maybe this wasn't too hard for Miss Fisher. I guess before I used those, I should have probably checked to make sure that all the angles were acute. In order to have the last name acute, don't forget, all three angles have to be less than 90 degrees. So let's check this one at the bottom. You can just put your, your joint right here in between. And you can just see that it's clearly not 90 because it would go straight up. Turn it. That one's not 90 because it would go, I guess that's nice to show you. Sorry, you're not here with me. So if I would just, if it was 90 degrees, it would have gone straight up like that. And it didn't. It went smaller. So I come to this one. And I think, okay, from this line, where would 90 degrees be? Dash, 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 right? It would have made an L. So that's where it would be. And I went, so I proved that this one down here was acute. This one up at the top was acute. And I just have to prove one more. So where would 90 degrees be on this one? If you're making an L, it would be there. I can't really tell. There's where the line actually is. So that's where the L would be, and I went smaller than 90 degrees. Therefore, because all three angles were acute, I get to give it the last name acute, or the first name acute. Pretty cool. So maybe that one wasn't as bad as I think. So if you have to draw an isosceles obtuse, then just make it wide and short, and that the arms are on the side. If you have to make an isosceles acute, make it taller and skinnier. And just make sure that not all three sides are the same. All right, I jumped ahead of myself. The one that is actually the hardest to draw is the one that's coming very last. So as I got drawing that, I was like, oh, that one's really not that bad. This one can be a little bit tricky. So here we go. It is a scalene acute triangle. Scalene acute, or an acute scalene. So to be scalene, we're going to use green, right? No sides can be the same. They all have to be different. To be acute, all three angles have to be less than 90 degrees. So in order to draw this, you really have to start thinking about not letting any side be the same length. So, or starting with an angle. So that might be a good way to start out, is just to start with an angle. So let's start with I guess I kind of want it to be a straight side over here. So if I start with an angle, like going straight down, that's one side of the triangle. If I were to make an L, that is not going to work because that would be a right triangle. So I can't make an L. It has to be acute, so it's going to have to close in more. So instead of going right on the line, I'm going to just go a little above it like that. And I can't go straight up because that's going to make an L, which would be 90 degrees. So maybe I need to go a little bit further. And then if I come up to that point, I want to make sure that it's not 90. Remember, 90 degrees would be making an L. So here's what I'm talking about. If I were to do that, that would be a 90 degree angle. So I'm trying to go in like that. And what's tricky is that almost looks like a scalene, an isosceles triangle. So you have to make sure that no sides are the same. So this is where using a scratch paper is going to be really important. Okay, so I'm going to use a part that I haven't used. Well, I'll just erase the tick marks. Okay, so I have this line a little bit lighter because I'm not 100% sure yet. So if I went from this vertex up to that point, that is how long it is. See on my scratch paper here? That's how long it is. So now I'm going to make sure this other side was not that long. So I used the same paper, vertex to vertex. And it's not. That's good. This one's a little bit longer, so that's good. And then I'm going to make sure the base is a little more obvious that it's not, but it's good to check. Okay, so none of my sides are the same. I am a little worried that my line wasn't straight here. So I might just fix that a little bit for myself. Okay, and you need to prove that by showing side 1, side 2, and side 3. That proves scalene, right? Because none of them are the same congruency marks. We'll use green on all the sides though, because that would be important. Ooh, that's so close to this one we just did, the isosceles acute. So you just need to really make sure that those two sides were not the same in length. And then I can already tell based on the angles that they're all acute. If you need help checking that, you can ask a parent or you can ask me. But that should be pretty obvious that they're all acute. There we have it. We have drawn a lot of different types of triangles. In order to continue on with what else we have planned, you really need to understand that triangles are classified with first and last names. That's how Ms. Fisher calls it, but really they're just classified as different things. They can be an isosceles, scalene, or equilateral based on their sides, their measurements, their congruency measurements. And they can also have an angle name, obtuse, right, or acute. So refer back to this as much as you need to. You will definitely want to use it when you complete the Think Central assignment for 8.15, which you're going to do right now after this lesson. And then you'll find out later about when to do the homework and remembering. Hope you learned a lot about triangles.